Okay, let's look at this question. It's the Mpumalanga 2020 trial paper question on Newton's laws. It says block A of mass 2 kilograms is placed against block B, mass 4 kilograms on a rough horizontal surface. So here are our two blocks over here. The following table supplies the frictional forces that are experienced on each block. So we've got static friction over here and kinetic friction over here. So it says a force of 15 newtons is applied horizontally on block B as shown in the diagram below. State Newton's second law in words. So obviously Newton's second law is when a net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the force and inversely proportional to the mass of the object. So it now says to you block B is exerting a force F on block A. So there's block B. Can you see it's exerting a force on block A, and block A is to the left of it, so the force must be going to the left. It says now write down the magnitude and direction of the force that block A exerts on block B. So this is obviously Newton's third law, that for every action there's an equal and opposite reaction, which you're not allowed to say. You need to say the full proper Newton's third law. So obviously what's happening here is if block B is exerting a force F to the left, block A is exerting the same force F but to the right. So if we were doing this with vectors, we would say that the force is minus F, or we would say F is the magnitude, F newtons to the right, because you can see if block A is having a force on block B is fairly obviously to the right of block A. Now it says to you the following statement is made. Because the applied force on block B is more than the maximum frictional force of block B will accelerate to the left. And it says explain in terms of net force and motion why this statement is false. So if you look in the memo just says if there is no net force, the block is not going to move. And so it says there's no net force, the block is not going to move. So I kind of thought that answer in the memo was a bit of a cop-out. I didn't really 100% agree with it. But what I did think about is that if you've got this block B, you've also got block A pushing on it, and block A's also got friction going this way. So they've actually both got friction. And if you look at the friction for block A, it's 5,88, and if you look at the friction for block B, it's 11,76. And if you add those two together, they're both more than 15. And so I'm like, okay, well, you might overcome the friction on block B, but you're not going to overcome the friction on block A, so the block can't move. But the memo was just fine with saying there's no net force, and so the block is not going to accelerate. So basically you've just taken this second law here and you have said, okay, if we're not accelerating, it must mean there's no net force if there's no motion. Okay, now for the more interesting part of the question. It says to you the 15 Newton force is removed and is replaced with an unknown horizontal force, Ft. Okay, so we're going to have Ft going that way. So it says the blocks accelerate at 4,5 meters per second to the left. So they're going that way. So we know Ft has to be that way because the acceleration is that way. Now it says draw a labeled free body diagram for block B. We know if we're going to solve this problem, we're going to have to draw two labeled free body diagrams, but let's look at block B. Fairly obviously, the first one, please draw this with your ruler. Straight down is the weight, then straight up is the normal force. My goodness, this is really a terrible picture of the weight. Let's try and draw the weight a bit more neatly. Okay, so for block B, we've got the normal force because it's on a surface, and we've got the weight. We know we've got Ft. Arrows always come out the free body diagram, so there goes Ft. If the blocks are accelerating to the left, we know we've got kinetic friction going this way, and it should be a little bit shorter than your Ft because obviously it's not stopping the motion. So there is my force of kinetic friction. And now we've got four forces, but you can see here the memo says 5 marks. So if you're confused where the other force is, Look back up to 2.2. Block B is exerting a force on block A, which means block A is exerting a force on block B. And we even got asked to describe which way it's going. So this is another force over here, and it's the force of block A on block B. So those are the 5 forces that are being exerted on block B for your 5 marks for your free body diagram. Now it says apply Newton's second law on each of the blocks to calculate Ft. The moment it says that, we have to draw a free body diagram for block A as well. So here comes block A. It's also got its weight downwards. It's also got its normal force upwards. It's also going to have kinetic friction going to the left because it's moving to the right. And then it only has one other force, and that is the force of B on A. Okay, remember the 2 blocks are touching, so there's the force pair from Newton's third law on each other. What you need to remember now is that FA on B equals FB on A. Okay, so the magnitude of these 2 forces is going to be the same. So when we make our equations here, we're going to go for block B, F net equals MA. So block B's mass is 4, and they said to you in the question the acceleration is 4,5. So we've got the right hand side of the equation. Now we need to look at all the horizontal forces. So if we say this way is positive, okay, we're going to have Ft minus Fk minus Fa on B. Okay, and then we're going to look at block A, and we're going to say F net equals MA, and we've still got direction of motion is positive, so FB on A minus Fk is going to be equal to the mass of block A, which is 2, and this is also being multiplied by 4.5, okay, because that was the acceleration. So we can now put some values in here. We're looking for Ft. We don't know Ft, but from the table here we can get the Fk values. So for block B, the Fk was 4,70, so we're going to subtract 4,70, and then we don't know Fa on B, so we're just going to leave this like this for now, and 4 times 4,5 is going to be 18. So then I have Ft minus Fa on B equals what? 18 plus 4 is 22,7. Okay, so let's go back to block A and see what's going on block A. We're not quite sure what's B on A, okay, but we know the force of kinetic friction for block A is going to be 2,35, and it's against motion, so we're subtracting it, equals 9. So this is going to be, by algebra, 11,35 equals the force of B on A. Okay, but we know that the magnitude of B on A is the same as magnitude of A on B, because it's a force pair for an equal and opposite reaction. So I'm going to take this 11,35 here, and I'm going to substitute it into the other equation. So Ft minus 11,35 is going to be equal to 22,70. So Ft by algebra should be 34,05 newtons. So, and of course it's going to the left, but they told you that in the question, so they maybe don't want it in the answer. So the whole trick here is to remember that these two are a force pair and they're acting on both the blocks, so that might be a force that you didn't think about at the time.